Hello Simmers, welcome to Amsterdam Airport Schiphol, where we are parked with the Felis 747-200, an airplane that released in September last year. I've had it in my hangar since day one. Purchased it immediately because this is the type of airplane that my own father used to work with at KLM. He used to be a so-called ground school instructor, meaning he was a full-time uh, level D flight simulator instructor. KLM was one of the few airlines in the world that had dedicated ground staff for that and didn't work with training captains as most airlines do. But during the early zeros with the baseline program, that all changed, and he had to do other work. But this has always been his airplane, and I have always had a weak spot for the classic 747. So I really wanted to do a video on it, but if you want to do it properly, you have to do a long haul, and long hauls take a lot of time to fly, let alone make videos about. And time is something that I didn't have too much since I purchased it. So this is going to be an attempt to show you a flight long haul from Amsterdam to San Francisco, California. So it's going to be an 11-hour flight, a little longer than that. I think it's going to be 11 hour 15 minutes or something like that. And of course, that is way too long to put in one video. So what I've decided to do is create a video series. This is part one of four. In this part, we will take a look at the pre-flight. We'll set up the airplane, and as soon as we are fully ready for push and start, that's when this video ends. And when the second part starts, so part two will be pushback, taxi out, take off, and climb. Part 3 will cover most of the actions that you will have to perform during the cruise phase of a long haul flight. So that will mainly look deeper into fuel management. I think the INS updating will be covered in the climb out phase, but I will get back to that later. But cruise, so that is fuel management, vertical navigation, meaning step climbs, when to do a step climb, INS updating when it comes along. And once we have covered most of that, that will be the end of part 3. And then part 4 will be the descent preparation, descent, approach, landing, and taxi in San Francisco. So there's a lot to do. I want to depart at 10 a.m. locals, which means we have 1 hour to set this bad boy up for push and start. So a quick tour along the exterior. As you can see, it's beautifully modeled. This livery was downloaded from the forums over at explain.org. It's the Danube. Um, that's what the plane was named. The first series of 747s that KLM purchased, they were named after large rivers. So you had, I think the first one was the Mississippi, the Bravo Uniform Alpha, and this is the Bravo Uniform Bravo, and this was named the Danube. And as you can see, it's just a beautiful, beautiful rendition of this airplane. It also shows one of the downsides of this add-on so far, and that is that you cannot open the cabin doors. And that's basically the biggest, yeah, how do you call that? That's one of the few things that I don't like about the airplane. I mean, they have modeled everything in great detail, but you cannot open the cabin doors, which I think is, yeah. I hope they will implement that in a future update. But let's just jump on board, step into the flight deck. And as you can see, the flight deck is beautifully modeled. And what we're going to do is just start her up. And while we do that, I will talk a bit more about the different systems, etc. But the first thing that we need to do is switch on the battery. That's located on the flight engineers panel. So switch the battery on and set the standby power to norm. Then you can jump into the EFB. That was the wrong key. Go to ground, ask
Cockpit
for
to ground.
chocks.
Put the chocks on. Chocks are on. cockpit to ground. Connect ground power.
Okay, so we have asked for ground power, and once it is connected, you will see that the exterior power lights illuminate, which they have been.
Ground power connected.
All right, so we can set the ground power to the buses. Then we can jump back to the pilot's position, switch on the nav lights to inform the ground crew that the airplane is now on external power. We can switch on the radio master switches. And what I always do first is start with the alignment of the INS. So move these switches to align, because aligning can take some time. So it's actually quite nice to have the alignment running in the background while we start the full preparation on the flight engineer station. But first thing we have to do is set the INS for align. So we have set the switches to align. And now what we have to do is we have to enter the present position of the airplane. So in the cockpit there are 3 INS units, which are, by the way, fully modeled, and they ship with the airplane. So you don't need the SIFA INS for this add-on. This is just custom built by Felis to suit this airplane. So what you have to do is you move the selector knob to the position mode. And I will get back to the INS in more detail later on in the flight when we have to enter our flight plan. But for now, just follow the steps. So it's to the POS page. Now we are in Amsterdam and we are parked at gate Foxtrot 3. So we have to take a look at the, so that's down here, at the parking stand coordinates for Fox 3. And that is down here. So it's north 52.18.7. So north 52.18.7. Press insert. By east 004457. So 004457. Insert. And we do that for all 3 stations. And what's very important is you have to make sure that the waypoint counter is at 0 and the selector knob is at pause. So north 52187, check, insert. By east 004457, insert. And also on this one, this is at 0, pause. So north, what did we say, 52187, 52187, insert. By east 004457, insert. And now we have the INS aligning. Now if you want to see the status of the alignment process, you move the gray selector knob, the bottom half, all the way to the right to the DSRTK STS system. And when you do that, you see that the displays change, and the right display is important. 0 indicates that the system is aligning. Once the alignment has been completed, this will change from 0 to 1. 8 is a countdown timer. This will count down from 8 or from 9, I think, down to 1. And it shows the level of accuracy of the INS at that particular time. The closer the value is to 0, the more accurate the INS will be. Now 5 is a desired value. Once the countdown timer has reached, in this case 5, you will see the INS ready light, the ready nav light illuminate, and you can switch the INS from align to nav. However, I don't want to be with an accuracy of 5. For this flight I want to have an accuracy of 2. So I'll press 2, insert, and also in here 2, insert. And now the nav ready light will only illuminate when the countdown timer has reached 2. So having done this is really important to have this run in the background. Like I said, it will take some time to complete. We'll just head over to the flight engineer station and we'll start the setup from the airplane from here. Now what we do first is we'll have to set the weight and balance of the airplane. So just go to the EFB And in the EFB there's a number of options that you can set. So I set the nose wheel to the yaw, so I can steer on the ground with my rudder pedals. But if you like to steer with your yoke, you can set it to roll, or you can set it to a tiller, and then you can configure a tiller, like for instance a side stick or a joystick that you might have to operate the tiller. The nav system is INS. You can use an FMC. Just move this from INS to FMC and you will get a control display unit in here for just regular FMC operations. Now the units, I'm a European guy, so I'll use metric. I set INS align and source both to real, so it will be as long as it would take in the real world to align. I have synced the captain gauges to the first officer. And that's quite convenient, which means that I only have to set, for instance, the QNH on the captain's gauge, and it will automatically be set on the first officer gauge. Some people like it, some don't. If you don't like that, if you want to set every gauge yourself, switch this off. I like it switched on because, well, when you are flying with a multi-crew in the real world, the first officer will set his own gauges, so you don't have to set every gauge yourself either. The crew voices are on. You can set some cockpit volumes for both the external engines and the cockpit sounds. And I usually set auto throttle blocks user throttle to on. So if you accidentally push your throttles when the auto throttle is on, it won't disconnect immediately. But that's just my preference in the options. So what we have to do is we go to the load calculator and we have to take a look at our flight plan. Let me just generate it in PDF. That's a little bit more convenient. I use SimBrief because SimBrief has a very good performance file for the 747-200. And I see that I have the wrong format. This is Ryanair, and I don't want Ryanair formats. I want KLM format today, which is that one. So now I want to generate the flights. And there we are. So here we are. KLM. All right. So KLM 605 Amsterdam to San Francisco, January the 16th, 2022. We are Papa Hotel Bravo Uniform Bravo 747-200, which is correct. We are configured for 341 seats. And as you can see, we have total booked seats of 382. So that means we have 382 passengers out of a capacity of 388. So it's a full load. We have a dry operating weight of 175,000 kilos. Passenger weight will be 30,580 with a bag weight of 9,530, which will give us a payload of 40,110 kilos, which will give us an estimated zero fuel weight of 215,509, which is actually quite close to our max zero fuel weight of 238,000 kilos. So this is the figure that we are working towards in the load of the airplane. So 382 passengers and a zero fuel weight of 215,509. Now, if you take a look at the EFB, it is divided into 6 sections. On the top left, you will see the different compartments. In the middle left, you will see the weight for both the cargo and the passenger cabins. This is the amount of passengers, this is the amount of cargo. You can select some presets. There's a fuel calculator with the outcome of the fuel, of the inputs that you put in the calculator. You will see the outputs in here. And here are the final results which combine everything. Now, right now, the passenger count is 304. And we are looking for 382. So we need to add passengers. So let's put it like that. And now our zero fuel weight is 229,587 kilos, and we are looking for 215,509. So we need to get rid of some. So let's just offload cargo, because I don't think there was any cargo planned in the flight plan. And this is much closer. This is 215,889. Well, so we should lose 300 kilos, so we might just kick off a little bit of passengers. What I like to have is accurate zero fuel weight with the flight plan. I don't care if the passengers add up, I want the zero fuel weight to add up, because that's the basis for the performance calculation. So I want to lose 300 kilos. $509. Yeah, let's put it like this, 215,470 kilos. That should have us on the safe side. And what we also have to take a look at, we want to cruise at Mach 0.85. We have an air distance of 5,366 miles. So that's the distance that I want to put in here. So 5,366 will be 5,000, well, let's make it 400. We will climb eventually to flight level 360, but our initial climb will be flight level 280 because we are just too heavy to climb to 360 immediately. We will only reach 360 once we are over North America already. That's US airspace. Average wind component, we have a headwind of 34. So this says tailwind, so that will be minus 34. The distance to our alternate, that is Oakland. I think that is roughly 20, well, it's not even 20 miles if you look at it in a straight line, but let's just put in 50 miles for that one. And we have a total amount of fuel of 162,649. We are looking for a block fuel of 150,883. And we are also over the maximum takeoff weight, so we need to lose a little bit of fuel anyway. So let's reduce the amount of taxi time first. So let's just put it like this. Then at least we have the total fuel is 148,176. So that's only 2,000 kilos. Well, in this airplane, 2,000 kilos is like 4 minutes of flying time. So we'll just leave it at this. So then we go to home. We'll go to refuel. And I say pump in 148, or total fuel 148,176, which will be 148,500. And now you can have you have two options. You can call a tanker to reach the total amount, and it will do that in real time, which will take very long. I'll just use the instant refuel for this video. And for the payload, we are looking for 378 passengers. So people to board, just hover your mouse over the 0 and with your scroll button scroll up till you reach 378. And also in here you have the option to board, which will board the passengers in real time, or to just instant board and load. So I'll just go for instant board and load. And that's it for right now. So what I will do is I'll set the flight engineer's checklist on the screen already. And we'll go to the flight engineer stations to run the systems for our pre-flight. Now this may look like a labyrinth of knobs, switches and gauges, but there is a system to it, so I will walk you through it methodically. We'll start on the top left. This little panel is the APU panel. We'll do a squib test, make sure that the light illuminates. We'll do the fire detection test. sorry, the fire test is in here. Now, if you have your mouse cursor in a single arrow pointing upwards, you will only move the switch for system A. If you have the two arrows moving left to right, like this, then you move both switches up simultaneously. So let's do just that. That's the fire test. That's the full test for alpha and the full test for bravo. And we can start the APU already. And keep it up until the APU door light extinguishes. And now you can see the exhaust gas temperature is rising, the RPM is rising as well. Now the reason that I want to start the APU already is because the cabin temperature is quite low. It should be roughly at 20. And I can use the APU bleed air to set the cabin temperature correctly. So that's why we started up already. Okay, so now the APU is at 100%. We'll open APU bleed air. And then we can proceed down here. So we have duct pressure in here, and we can now open some pack valves. Make sure that the humidifier is off. I can switch the trim air to open. And now you can see in this row of gauges, which is the environmental control system basically, these gauges are divided into two rows. There's one gauge for each compartment in the airplane, and the top half of the gauge is the temperature inside that cabin compartment, and the lower half of the gauge is the temperature of the air that is flowing out of the air conditioning ducts. And this temperature can be controlled with these switches. Now, as you can see, the temperature is rising quite rapidly, so I will move this one down. And this one is also reaching 20, as well as this. And this one. And this one is also good now. Now, I find that usually when you leave the switch at the lower end of the second stripe above cool, it will give you roughly 20 degrees duct temperature. If you open the trim air, that will have the cabin temperature stable at roughly 20 degrees. So now the passengers are comfortably and warm. Oh, wrong key. We have the APU started. Let's proceed with the galley power so that the flight attendants can make coffee and meals and preheat ovens, etc. We'll set the galley lavatory fan to auto and the galley chillers to on. We are on external power. We'll just leave it there for now. But before we start the airplane, we have to switch the APU to the buses, disconnect the ground power, etc. But for now, we'll leave this like the way it is. Moving down, these are the engine controls. Each engine has a generator to generate electricity. Right now, the engines are not running, so all the gauges read 0, which is correct. Make sure that the bus tie switches are centered, the generator close switch are centered, and the generator open lights are illuminated. The field switches should be in the center position, and the pressure lights should be illuminated at the constant speed drives. Oil temperature is at its lowest. It sort of corresponds to the outside air temperature, which is alright. If you move further down, we have the engine controls. N2 is 0, which corresponds to the engine states of engines that are not running. The oil quantity is topped for each engine. Oil temperature is roughly the same as the outside air temperature. Oil pressure is 0 with the engines off, and the engine breathers are also 0. If you move a little bit further down, you have some light controls. I usually just move the panel and background lights halfway up, as well as the circuit breaker overhead and the circuit breaker manual light. And this little switch is the indicator lights test. So if you move this one up, every light bulb on the flight engineer's panel will illuminate. So you can check that all the lights are working and no light bulbs need replacement, which is correct. So we'll switch this off again. Moving one panel to the side, we come at the fuel system. Now, of course, if you look at it from top down, The fuel used, that's per engine. Of course, the airplane has 4 engines, so this will indicate the amount of fuel that each engine is consuming. This little gauge gives you 2 weights. The top number is the gross weight, which means it's the airplane zero fuel weight, including the added on the zero fuel weight is the fuel weight, and the lower half is just the fuel weight. Now 148,400 kilos, that is correct. We put in 148,500, but the APU is running, so that is consuming fuel, so it's now lower than 148.5, which is perfectly normal. The fuel temperature is just below 10 degrees, which is fine. The fuel pressure is 0 with the engines not running. The fuel heats are off. We can press this button to test all the gauges. Press and hold it for a while to get the air 0. And now it will run a test. Now, what's also important to check is that the fuel that is on board is distributed equally amongst the tanks of the airplane. Now, the center wing tank will drain first, then the number 2 and number 3 main tanks, and once the number 2 and number 3 main tanks contents has reached the same number as the number 1 main and number 1 reserve added up to each other, that's the point in flight where you will close the crossfeeds and have each engine fed fuel from an individual fuel pump. But we'll get back to that later in the fuel management part in the cruise. But for now it's important to see that the number 1 and number 4 reserve tanks have an equal amount of fuel. Number 1 main and number 4 main have an equal amount. Number 2 and number 3 main have an equal amount. Number 2 is starting to decrease. That's because the APU is draining its fuel from the number 2 fuel tank, so that's perfectly normal. And that the difference or the leftover is put in the center wing tank, which is also done. The scavenge pump is off. And for now we are good. Let's just open the reserve valves. And that is the configuration that we need for now. We'll switch the boost pumps on. And that's the fuel panel already completed. So let's move up. Now here's the AC meters. They read 0 because engine generator number 1 is selected. And of course the engines are not running. But if I go to the external power, I'll get readouts, and if I go to APU generator, well, it's not on the buses, but it is working, so that is correct. For now we'll leave it at external power 1. This was already set, so there's nothing to see there. Packs, we can open the engine bleeds, and we have to make sure that before we start the engines we close the pack valves, but for now we need them for the cabin temperature. So this configuration is good for now. Pack controls are in auto, humidifier is off. We just looked at the environmental control system, so that is all working. What we do have to do is set the pressurization for the cabin. That is down here. This is the pressurization panel. Our initial climb will be to flight level 280. So I moved this gauge, turn this knob to 28. Because this gauge is divided into 2 halves. You have the left side, which is the black background with the white numbers. That is the altitude in thousands of feet, so 28 is 28,000 feet, at which the airplane is flying. And the right half, the white background with the black numbers, that indicates the cabin altitude. So that's the altitude that the pressurization system has to set inside the cabin. Now we have to take a look at the weather information in just a minute and set the correct QNH. Although we can do that right now. Let's just go to performance. Get back to this later. It's 1022. So 1022 has to be set here. Which is like 301. What is it? 6, something like that. So let's just dial this one up to 3016. All right. This is also part of the pressurization system. This is the rate of climb or descent that the pressurization system is maintaining to adjust the cabin pressure. This altitude gauge will indicate the cabin altitude. So the needle on this gauge has to correspond to the number in the right hand side of this little gauge. So if this says at 28,000 feet you have to be 2,150, then on this gauge the needle should indicate 2,150. This is the differential pressure. Well, that speaks for itself. Altitude horn Carnot, we cannot do that. The rate limit test, we can test whether the flow valves are working and the indication needles are moving freely, which they do, so that is fine. There's nothing to test on the environmental control system, so let's move to the fire warning panels in here. Let's do a script test for the left and right bottles, that is completed. Equipment cooling, we can test for smoke detector, that's working. We can test the blower selector, so there's no airflow, that's checked. Aft cargo heat, we can test it, make sure that the lights illuminate in green, which they do, and then we can immediately switch it to normal. And you leave it in normal until you have landed at your destination airport. Lower cargo fire protection, we can test system Alpha, system Bravo, and both systems at the same time and check for the audible warning, which we have heard. And we can also do a script test on bottle 1 and bottle 2. Engine fire detection, we can do a fire test. As you can see, the lights illuminate, we have the audible warning. And we can also see the temperature indicators, they were moving as well. We can do that for system Alpha and Bravo as well, so they are working correctly. Moving down, we get down to the hydraulic system. What we have to do is set the electric hydraulic pump to on, and that will pressurize system 4 to 3000 psi, as you can see right here. The hydraulic temperatures are normal, the air pumps are in the off position, and the engine pumps are in the normal position. Hydraulic quantity is on the top of the green line for each system, so that is correct. And the APU hour meter, well, that's just nice to know. Moving back further to the right, the wing leading edge overheat system, we can test system 1 and system 2. Check that there are no strange warnings on the indicator panel. Brake monitor, we can test whether everything is moving freely, which it does. The overheat light was working. Now the anti-skid lights are on, and that is because the anti-skid system is off. Once we switch that on in the pilot's pre-flight, these lights will extinguish. No warnings on the landing gear. Now this is the flight data recorder, and you can actually record your flight. And from the website of Felis, you can download a little program that you can use to then replay your flight, so you can check all your inputs, etc. I haven't done it myself yet, but it's actually pretty cool that they've modeled this in here. So what we'll do is we'll do a lamp test, make sure that all the lights are working, and I'll just leave it for this right now. The anti-skid landing gear tilt inputs, we do a primary and an alternate test. The lights are working. Potable water is full, so that is good. And finally, we have the fuel jettison panel, which is fully modeled, everything works. Make sure that all the pumps are off and everything, all the valves are closed, which is the case. We'll close the cover, and having done that, we will start to run the flight engineers before start checklist.
Battery on. APU panel. Check. Auxiliary power. Check. Engine oil quantity. Check. Fuel quantity. 148,410 kilograms. Fuel panel. Check and set. Pressurization controls. Check and set. Bleed controls. Check and set. Hydraulic quantity. Check. EPR computer.
Oh, that's
Let's
one
see.
we have to do. That's in here. This is the EPR computer and we have to set it to go around.
Go around. Circuit breakers. Check. Indicator lights. Check. Electrical panel. Check and set. Air conditioning controls. Check and set. Fire control and wing overheat panels. Check and set. Equipment cooling. Check. Passenger oxygen. Check. Hydraulic panel. Check and set. Fuel jettison panel. Check. Crew oxygen. On. Oxygen mask and regulator. Check and emergency off. ADPs off. Checklist completed.
Right, so this concludes the flight engineer's pre-flight. So let's move to the pilot's position and run the pre-flight in here as well. Let's start at the overheads. On the left overhead, make sure that all the covers are closed and that the yaw damper switches are in the center, which they are. Auto brake is off. Now we can switch the anti-skid light on, and that will extinguish the anti-skid lights on the flight engineer station. So if I switch this on, you can see that now the lights are out, so that's good. So let's go back to this one. We can arm the body gear steering, make sure that the, or at least set the panel lights as you wish, as you like them. Make sure that the landing lights and the runway turn-off lights are off. We can set the long-range radio. I usually set it to AM and never really use it, but just for purposes. Alternate gear extent. Make sure that the guards are closed. The compass should be slaved. Engine ignition should be off. Now the INS ready nav light is illuminated, so we can switch the INS to nav on all three systems. We checked the engine fire with the flight engineer's pre-flight. What we can do is test the wheel well fire. So that is working. We can also test the cockpit voice recorder. Make sure that the needle moves. This one is set to nav. Start valve, we can leave that off for now. Ignition can be set to norm, that's fine. Emergency lights are armed. We can do a quick PA for the passengers.
Ladies and gentlemen, this is your captain speaking. On behalf of the entire crew, welcome aboard the Boeing 747 Classic. We will depart shortly after we have our clearance and the cabin crew is finished with their preparations. For now, I wish you a pleasant flight, and I will be back during the flight with further flight information.
So no smoking, fasten seatbelt signs are on. The windshields, these are the washers, the wipers, well, they are all off. They're not required for now. External lights in here. Nav light is on. Make sure that the rest is off for now. Before you run the checklist, you have to set the beacon light to on. But for now, I'll just leave it like this because we are not ready to depart. So set the long range radio for the first officer to AM. Make sure that the alternate flaps are all in off. There's not much we can do in here. There's not much we can check or switch. The compass is slaved for the first officer. The engine ignition switches are in the off position. The INS is set to nav. Engines were checked. Radio masters are on. Stall warning is tested. The Mach airspeed warning is also tested. Over rotation tested. Nacelle anti-ice is off. Wing anti-ice, we can run a ground test. Both lights illuminate, so that's successful. Move the switch to off again. Probe heaters, we can do a test. Make sure that the lower lights extinguish. Back to off, all lights illuminate, and when you switch them on, all lights should extinguish, which they do. We can switch on the window heat, and we can run an indicator lights test for the pilot panel. So the overhead has all the lights working, and then we'll move to the sides, and we'll see that the, we'll just hide the yoke for now. All the lights here are working as well. So indicator lights test is completed. Now let's continue with the captain or with the pilot's pre-flight. Let's first do the panel flows and then we'll set up the gauges. So this is all good. We can set the QNH, which was 1022. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. just realized that I made a slight mistake with the flight engineer. It's 3018 and we set the pressurization to 3016. So let's just dial this one up to 3018. There we are. So having set this, oh, this is all good. Check the inner, outer and middle marker lights by pressing them. Do that as well for the first officer. We can do an instrument warning test. What you expect to see is all the lights on this and this panel illuminate, and the warning light should be flashing. When you release, the warning light should keep flashing, so we'll just press it to switch that off. Panel lighting, just adjust it to your liking. We'll come back to this later. There are no strange indicators on the warning panel. All the engine's indicators are normal. The flaps are 0, that corresponds with the flap lever. The gear is down, so is the light indicating down, so that is also in line with each other. The speed brake is stowed, parking brake is set. We can do a takeoff configuration test by just advancing the thrust levers and make sure that we hear an audible warning, which we do, so that's tested. And moving down here to the radio panel, frequencies are set. Well, let's say that we just copied our clearance and we have to squawk 2205. This is the EPR computer. Well, it's in go around mode for the engine start. After engine start, we have to set it to takeoff dry and select the mode that we want to use. For now, I'll just press the test button. That's all right. The weather radar is in standby. And that's basically it for here. If you go back to the center panel, there are some warnings hidden in here. So just max indicate reset. Let's do the altitude alert test. And then the ground proximity test.
Pull up. Glide slope. Glide slope. Pull up.
And the rudder ratio, you should see this warning light illuminate, which it does, so that is also good. Right, so that's the panel flow for the pilots. What we have to do is set the performance. So go to your EFB, go to performance calculation. Now in the performance calculation, the screen is divided into 4 sectors. So that's 1, 2, 3, 4. The top left, just press read data from sim. That will give you the actual weight for the simulator. Now I want to use flaps 20 for takeoff. And we're going to fly out of here runway 24 in Amsterdam. And runway 24 has a runway length of 3,439 meters. So let's dial up the runway length to 3,400. The airport elevation is 0. The runway heading is 24. Weather condition, the runway is dry at 7 degrees Celsius. We have 1022 for the QNH. The wind is 250 at 9 knots, 270 at 9 knots right now. This configuration will give us the following V speeds: V1 of 158, a V rotate of 167 and a V2 of 176, which will correspond to a flaps 10 speed of 196 knots, a flap 5 speed of 216 knots and a flap 1 speed of 236, and we can retract the flaps fully at 256. This means that we ask ATC on our departure for a high speed climb so that we can retract the flaps fully and climb out at the optimum climb speed of 338, which will probably be 340 knots on our indication. Now, as you can see, this is the airspeed indicator. There are a number of white bugs. If you press the set speed bugs here on the EFB, you will see that these bugs are set in the correct position immediately. So let's do just that. And we set V2 of 176. Make sure that that is set in the speed window on the MCP. The departure that we will be flying out of Amsterdam will be the Falco 1 Sierra departure, which means we have to take off with an initial heading of 237. So dial that into the heading window, 237. And the initial altitude out of Amsterdam is always 6,000 feet, so we can dial that one in here. Don't have to look at the charts for that. And make sure that the alt select is engaged. So we'll just fly out of here and we'll intercept this radial towards Falco, which I happen to know is the Papa Alpha Mike radial. Papa Alpha Mike is a VOR station that is located somewhere down there, which has a radio frequency of 117.8. So I will set 117.8 as my nav1 frequency, and I will set course 250 in here. And I will set my nav2 to the Sierra Papa Lima VOR, which is 108.4, which is basically the airport VOR. So I now have two values in my DME windows. DME1 is the Papa Alpha Mike VOR, 12.2 miles away, and we are 1.2 miles away from the Sierra Papa Lima VOR. So whenever there's an emergency, we contact ATC and we give them our distance relative to the Sierra Papa Lima VOR. So that is also set. Now the last thing that we have to do is enter our flight plan in the INS. So what you have to do is set this rotator switch to waypoint. And if you don't want to enter each waypoint in all the three systems separately, but you want to make one entry that will then be copy pasted in all three INS systems, you have to set the remote light on. So make sure that remote light is on each unit. And for the first waypoint, we'll use number 1. You will never use position 0 for waypoint entries. This is only your initial coordinate for the departure gate. This is where you initially align the INS on, and you will never change that. So you first waypoint is at 1. You can store 9 waypoints in here. And once you reach waypoint 9 and you want to do your 10th waypoint, you don't add it at 0, but you insert it at 1. So 9 back to 1. Never use 0. So we are waypoint mode, we are waypoint 1, remote is on each unit. So right now we have to take a look at the flight plan and start punching in some data. Now in the KLM flight plan, you get the list of your waypoints, but there is no latitude or longitude mentioned in the list. In the KLM layout, it is all mentioned here at the lower part below the alternate waypoint layout. So here are all the waypoints that we need. So the first one that we will enter is Alpha Mike 001, which corresponds to this one. So we can store 9 waypoints, so it will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So during the climb out, we immediately have to start updating the INS. But as you can see, this is basically pretty much a straight line. So I might just go from 8 to 9. That gives us a bit more time, and it's not much use to put in each individual section in here. That's just a simulator liberty. But anyway, let's start with punching in the numbers because we are 15 minutes away from our pushback, so we have to start moving. So Alpha Mike 001, that's north 5216.5. So north 5216.5. Insert by east 004421. So 004421. Insert waypoint number 2. That will be north 5214.6. So north 5214.6 by east 004391. 004391. Inserts waypoint number 3. That will be Alpha Mike 009er, north 52134. North 52134. Insert by east 004333. Insert waypoint number 4 will be Falco, which is north 52043. So north 52043. Let's verify that. Yeah, that's correct. Insert east 003504. Insert waypoint number 5 will be Idrit, that is north 51598. North 51598. Insert by east 003298. 003298. Insert waypoint number 6. That will be upnet, which is north 51510. So north 51510. Insert by east 003103. 003103. Insert waypoint number 7. That will be Hypnos, which is north 51489. So north 51489. Insert by east 002400. So 002400. Check that one. Yeah, that is correct. Insert waypoint number 8. So that's 1, 2, 3, 4, 5, 6, 7. Waypoint number 8. That will be Xaman, which is north 51471. North 51471. Insert by east 002134. 002134. Insert. Now waypoint number 9, as mentioned, I am not entering this one, but I will enter this one immediately. It's a straight line, so that's Wesel. Wesel is here. So that will be north 51403. So north 51403. Insert by east 000292. 1, 2, 3, 292. Insert. So that's 9 waypoints inserted in this one. If you move this switch to waypoint and you rotate through the counter, you will see that you have the exact same values in this one, but always check that that is the case. And also do that in this unit. And you can see that everything is nicely copy pasted into it. So that's good. You can press the remote buttons. And now there's one thing that we have to do, and that is if you go to the DSRTK STS mode, you have to set the INS into mode 4. So press 4 and insert. And this will make sure that the INS units are talking to each other. They give each other the position that they have calculated that the airport would be. And then the average of those 3 calculations is presented to the pilots. It's quite complicated. I'm not going to explain it too deep. Just make sure it's in mode 4. What I usually do is I set the wind information on this INS unit. So make sure that this one is in wind. And I always go for the distance and time in this one. And for the track and ground speed in this one. That's what I like best. So now I have the track that the airplane is flying, the ground speed at which it's flying at. I have the distance in miles from the next waypoints and the time in minutes that it will take the airplane to reach that waypoint. And since we are standing still, it's going to take indefinite. It's going to take forever to reach the next waypoint. And in here I have the wind heading and speed in knots. So that's quite convenient. So having done that, we have set up the INS. We have set up the performance. We've run the checks. So let's just run the checklist.
Before start checklist, please.
Gear lever and lights.
Down and check.
Brakes.
Parked.
Start levers.
Off.
Radios.
On and check.
Flight control hydraulic power.
On.
INS.
Check in nav.
Compasses.
Slaved.
Window heat.
On.
Seatbelts and no smoking.
On.
Emergency lights.
Armed.
Exterior lights.
Oh, we have to set the beacon light on.
Check.
Flight instruments.
Check.
Altimeters and clocks.
1, 0, 2, 2. Set and cross check.
I just
Radio
noticed that
INS
the
switches.
GMT is 1406 in the
Radio.
sim, so I have to
Radar
set
and
real world
transponder.
time in a minute.
Standby.
Indicator lights.
Check.
Engine and wing anti-ice.
Off.
Stall warning.
Check.
Mach airspeed warning.
Check.
Auto brakes.
Check and off.
Body gear steering.
Arm.
Anti-skid.
On.
Autopilot and flight director.
Check and off.
Takeoff warning.
Check.
Auto flight enunciators.
Check.
GPWS.
Check.
Instrument warning.
Check.
Flight director computer selectors.
Check.
Instrument source selectors.
Normal.
Reserve brake valve.
Closed.
Spoilers.
Down.
Static selectors.
Normal.
Oxygen mask and regulator.
Check and emergency off.
Brake pressure.
Check.
Stabilizer trim.
Check and on.
Rudder and aileron trim.
Check.
Checklist completed.
Alright, so that's the checklist completed. Well, as I mentioned, I just noticed the GMT says 1407, while it should be 854, so I guess if I go to flight configuration, yeah, I have to customize this, set this to track real world time and data, so apply changes, oh, done. So this is much better. Okay, let's pre-plan our pushback. Let's see, what are we going to do for the pushback? We can just push straight back like this, start up and then taxi out at our own. I'm not really sure what the correct real-world taxi or pushback procedure is for this gate. It might just be that they push back and straight onto the taxiway, but I know in Amsterdam that's not usually the case, so I'll just push back straight back so that we can taxi out on our own in here. So.
All right, Captain, got the directions. Let me know through the menu when you're ready.
Right, so we have to do a couple of things before we can manage the pushback. First of all, we have to tell the cabin crew that they can close the door and arm the slides.
Cabin crew, arm slides.
And that will give us a
All doors are closed and armed.
Roger, thank you. Then we have to set the APU to the buses, so close these fields. And we can contact the ground crew to disconnect the GPU.
Cockpit to ground. Disconnect ground power.
And we can call in the pushback tug.
Great news, Captain. Your tow's coming.
Ground power disconnected.
Ground power is disconnected. Okay, please remove the
Cockpit
chocks.
to ground. Remove the chocks.
To release your seatbelt, lift the upper portion of the buckle. We recommend that you keep your seatbelt fastened while in your seat. If you are seated next to the emergency exit,
Chocks removed.
instructions on the safety on board.
Alright, so we are good to go. As soon as the pushback tug is connected, that will be the end of this video. You can hear the flight attendant give her a talk in the back.
All right, looks like the doors and hatches are closed and we're ready to connect.
And that's nice on time. I wanted to depart at 10 a.m. and I It looks like that's going to work. So the packs are off. Now you can see that I switched the packs off during the flight engineer's checklist. You can immediately see that the cabin crew, the cabin temperature is much lower right now. So let me just give the cabin temperature a boost for a second.
Welcome aboard, Captain. Toes connected, bypass pins inserted. Go and kill the parking brake when you're ready to go.
Okay, and while the cabin crew is, or the cabin temperature is restoring to 20 degrees Celsius, let me take the opportunity to thank you for watching this video. This was part number 1, the pre-flight for our long haul from Amsterdam to San Francisco. I hope it gave you a little bit of more information on how to set up the airplane for a long haul flight. And I hope to see you in part number 2 for the pushback, startup, taxi out, takeoff and climb out. Where we will cover some of the procedures concerning those phases of flight. And after that, in the third part, we will take a look at the cruise, the fuel management, the altitude management, INS management, and updating throughout the flight. And then in the final part, we will take a look at the approach preparation and landing, as well as the taxi and the shutdown procedure. So let's just raise that temperature. Anyway, I'll set this and I'll see you in part number 2 for the pushback. So thank you for watching and bye bye.